Hi, this is Sung and I'm the Principal and Director of Sky Academy, and in this episode we'll be continuing on with our symmetry properties of trig ratios, and we'll be, now that we've done the second quadrant relationships, which is these ones over here, I want to now move on to the third quadrant and fourth quadrant relationships. And let me just take a departure from what we did to the second quadrant relationship, and that is I want to now start from the first quadrant and project our way to the third quadrant. Okay, so just say you have a right angle triangle in the first quadrant for the point P, X, Y. For the point P with coordinates X, Y. Okay, now let's say that that angle is an acute angle and that angle is theta degrees. In the third quadrant, we can draw a perfectly symmetrically corresponding angle by basically rotating this 180 degrees. So in other words, what's going to happen is the X and Y coordinates are going to be exactly the same, but they're going to be the negative version and not the positive version of what we have in the first quadrant. Does that make sense? So let's just do that. P, X, and Y. And that's going to be the negative version of that. Alright? So, what we've got here is a right angle triangle. And that right angle triangle is going to have X and Y coordinates exactly the same, but they're going to be negative. The angle here is going to be measured from the positive X arm and go all the way around. Do you remember that? But instead of that angle being theta, because we're basing that angle on the first quadrant angle here, instead of that angle being theta, it's going to be 180 plus theta. Does that make sense? So what that means is that sine 180 plus theta, cos 180 plus theta, and tan 180 plus theta is going to be some positive or negative version of sine theta, cos theta, and tan theta, right? Which is the sine, cos, and tan of the first quadrant angle, alright? Now, because these numeric values are going to be exactly the same, we can say that they're going to be equal apart from any sign changes, SIGN, sign changes that take place. So if this is sine 180 plus theta, we know that in the third quadrant that's negative. In the first quadrant it's positive, so we need to account for it with a negative sign. Cos is going to be negative. In the first quadrant it's positive, so we need to account for it with a negative sign. And tan is going to be positive, and in the first quadrant it's already positive, so we know that that's positive. Does that make sense? Good. We're going to do the same thing with the fourth quadrant this time. This time, in the fourth quadrant, X is going to be positive, Y is going to be negative, and we end up, it's the point P, X, Y, but this time, X is going to be positive, Y is going to be negative. So X dash, Y dash, right? The angle here is actually going to be this angle there. Does that make sense? And that angle there is going to be 360 degrees minus theta. Got it? So, sine of 360 minus theta, cos of 360 minus theta, and tan of 360 minus theta will be exactly the same as some version of the first quadrant equivalent. Except in this situation, in the fourth quadrant, cos is going to be equal directly to the first quadrant equivalent, but the rest are going to be negative. Does that make sense? The other thing that I want you to notice with the fourth quadrant is it can also be expressed not as the angle 360 minus theta. But I also want you to notice that it could also be expressed as theta going in the opposite direction, which means that it's going in a negative direction. So sine 360 minus theta is actually the same as negative theta. Alright? Sine of negative theta, cos of negative theta, tan of negative theta. So what you have here is that sine 180 plus theta, the third quadrant equivalent of the first quadrant angle, would be negative. For cos it would also be negative. For tan it will be positive, right? Which is basically what we have here. For the fourth quadrant, you can express the fourth quadrant angle as sine 360 minus theta, or you can express it as sine negative theta. Sine 360 minus theta or sine negative theta will equal to negative sine theta, positive cos theta, negative tan theta, negative, positive, negative again. Okay. The other thing that I want to show you is that if you add 360 to an angle, what you're actually doing is going back to the same point, P, X, Y. So that if you were to add 360 to the angle, the blue theta, you would end up going all the way around and going all the way back again. Does that make sense? So sine, cos and tan of 360 plus theta gives you sine theta, cos theta and tan theta again. Okay. So I just want you to be aware of that when we're doing the symmetry properties of trig ratios. In the next episode, we will work out where all of this is leading. Okay, so where is all of this leading? Why have we learnt all this? We're going to learn to apply what we've just learnt to problems of angles involving any magnitude. Thank you very much.